In this video, we'll be covering how to go from mass to particles and particles to mass using the conversion chart that you see on this slide. So first we're going to just dive right into this, assuming that you have some of the basics down on dimensional analysis, and then hopefully you can just pick up where I'm going from on here. One little side note about the atoms and Avogadro's number. So when you take a grouping in chemistry, a mole, that's this many atoms. Okay, and you need this many atoms, molecules, or formula units in order for something to show up on a scale. So why that number is so big, it's because atoms are so small that they weigh nothing, almost nothing. So you have to get this many of them just for something to show up on the scale. So what a mole allows you to do is basically turn the mass numbers that you see on the periodic table. It changes them from atomic mass units to grams when you take this many of them. So that's what it allows us to do. One extra note on a atom, molecule, or formula unit. So an atom is what we're going to be calculating in this example at the bottom. So this is just if it's just one element. Okay, then you would be calculating an atom. Okay, and Avogadro's number, it works for atoms, molecules, or formula units. A molecule is technically a covalent compound, such as and a covalent compound consists of nonmetals, so organic compounds such as CO2 or various gases made from the nonmetals. Like I'm just listing some small ones, or like SO2 or NO2, stuff like that. Okay, a formula unit is a ionic compound, like table salt, sodium chloride. So a ionic compound is a nonmetal, I'll abbreviate it NM, and a metal combined. Actually, I should write it the other way. It's usually the metal is stuck to the non-metal. So the metal is something from this part of the periodic table where you see that staircase. So these are the metals, and then these are the non-metals. These guys right here, with the exception of the last column. Okay, so like NaCl. So if you have one compound of NaCl, it's called a formula unit. It's not really called a molecule. So it's kind of a technical thing on naming stuff, but this is not a molecule. It's a formula unit. Okay, and when you're using unit analysis, you can abbreviate it as just FU when you're converting. Okay, so let's go into this problem. So what number of Fe atoms and what amount of moles of Fe atoms are in 500 grams of iron? Okay, so I'm gonna start off with my what this G and D here stand for is your given and desired information units. So your given and desired will be on this line right here, your given and desired units. These that you see down here are your conversion factors. So these are the steps you're going to need in order to change from this unit to, say, this unit, okay, or from this unit all the way to this unit here. Okay, so let's try this. So we have our given is 500.0 grams of Fe. Okay, so that means we're starting here at grams. Okay, and we want to figure out how many atoms that is, how many atoms of iron that is. So our desired is right here, atoms is right here. So we're trying to solve for this. And notice it's just Fe, so we're just solving for one element. Okay, we're not solving for a compound, a formula unit, like iron oxide. In that case, if it said how many formula units of iron oxide are in 500 grams of iron oxide, then our Avogadro's number would be formula unit and not atoms. Okay, so so we're starting here and we need to get right here. So to get there, we need to get to moles first. So as you see, we have to cross this bridge here, and then we have to cross this bridge here. So this problem should take us 2 steps. We're going to use this conversion factor, and then we're going to use this conversion factor next. Okay, and what we want to do, the strategy here is we want to get this gram, we want to line that up with grams of Fe here. Okay, and what this is showing is to get from mass to moles or moles to mass, we need this conversion factor, which is the molar mass. So we're going to look up iron, and we look at iron, and we find that iron is 55.85 on our periodic table. So I left this in this conversion chart. I left this blank because it depends what X is. Depends on whatever substance you're working with. So I'm going to write, so in this case, my conversion factor is 1 mole of iron is 55.85 grams of iron. Okay, so I'm going to write this piece right here. I'm going to write 55.85 grams of iron here. And the other half of the conversion factor goes here. 1 mole of Fe goes here. Okay, and then this unit cancels. If I stop the problem now, I will have moles of iron. Okay, which actually, I need that number actually. So I'm going to calculate that. It would be 500. Let me see if I can get this to display here. Okay, so I'm going to go 500 divided by 55.85, and I get 8 so this should have this number actually for sig figs. This number has 4 sig figs, and this also has 4. So molar masses are not exact numbers. They're based on they're relative to a mole, and a mole is defined as the number of atoms of carbon in 12 grams, exactly 12 grams of carbon. So these are not exact numbers. These in fact can go way, 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 like tons of digits past the decimal place. So we're going to use this number and round it after 4 sig figs. So my calculator shows, let's see, let me show you what it shows on my calculator. It shows this number here. So my 4th sig fig would be that 2 right there. Okay, so there's a 5 after it, so I'm going to round it up. Okay, so this would be, I'm going to save this answer because I'm going to keep going. I want to get to atoms of iron. So this is going to be 8.953 moles of Fe. Okay, I'm going to box that as part of that answer. And I'm going to keep going because I want to get to atoms over here. So, and right now I'm at moles. So right now I'm at this guy, and I need to get over here. So I need to use Avogadro's number to get from moles to number of atoms. So I'm stuck with moles here. So I want to write 1 mole here. 1 mole of iron is this many atoms of iron. So I'm going to write that half of the conversion factor here times 10 to the 23rd atoms of iron. Okay, and then mole of iron and mole of iron cancel. Okay, let's see. Okay, on my calculator, I still have this the mole number. So now what I need to do is times that, or I could just show you how you can enter this all at once. So I like using this this button here, and then this button. I like using this fraction form. So if I hit alpha and then this to get to F1, and then I select this one, this gives me the fraction form. And let me know if you want that. I have the program on my computer, and we could attach your TI, and we could put that new. It's like the updated software. It's not actually that updated. It came out in like 2013. So anyway, I'm gonna go 500 times 6.02. I like using this exponent button, which is where'd it go? It's second function. This one, this EE right here. So I go second function, E, and then 23. Okay, and then I put 55.85 on the bottom, and I get my answer. So I get 5. So this should also have 4 sig figs because of this number here. Avogadro's number I should use an extra digit. I don't know how many. This goes on forever. Avogadro's number. I cut it off early, but I think there's like a 3 here. I could be wrong. I think it might be a 2 actually. But I should be using this number, the number given in the problem, to limit my sig figs. So my answer is 5.389, and that's it, 4 sig figs, times 10 to the 24th atoms of Fe. Okay, so let's try one that's a little bit harder. This one here. It says Freon 12 is used as a refrigerant in air conditioners and as a propellant in aerosol cans. Calculate the number of molecules of Freon 12 in 5.56 milligrams of Freon 12. Okay, so I want molecules from milligrams of Fe12. So I don't see milligrams, I see grams on here. But there you can use the metric system to convert that to grams first. So we're going to go, and notice I put harder ones. So this is a little bit more challenging, especially the secondary question. So I'm going to go 5.56 milligrams of CCl2F2. Okay, and I am off this chart. I'm actually not even on this. I actually don't even have any of these. I have milligrams is what I have. And I need to get to here, molecules. Notice these are all nonmetals. So this is considered a molecule because it's covalently bound, like all the things here. It's held together with its shared electrons. So I need to get to grams first, and you can make your own conversion using the metric system. A lot of students like using this. King Henry died by drinking chocolate milk. For the most part, in chemistry, we deal with the base unit and milli. So you need to go either 3 to the right or 3 to the left. In this case, we need to go 3 to the left. And what I like to do is I like to say in 1 gram, I like to take one of the bigger unit and say there are 1, 2, 3 zeros, a 1 and 3 zeros milligrams. So there are 1,000 milligrams in 1 gram. So I'm going to use that as my first conversion factor. Then I'm going to use this, and then I'm going to use this. And then I'm going to use this one to get to molecules. Okay, so for the first one, I have milligrams here. So I want to take the milligram. I don't even look at the numbers, to tell you the truth. I just look at this, like a game, and you're just matching the unit. So I put 1,000 milligram here. And don't worry about multiplying or dividing or any of that. Just let the units do the work for you, and then you just enter the big blob in your calculator at the end. So milligram and milligram cancel. The other part of the conversion factor goes on top, 1 gram times, like that. Now I am here, and I need to get to moles. I need to get here. So I'm going to need the molar mass of Freon 12. And I like to use an app so to do molar masses, and I would encourage you guys to use this app. I actually prefer this app here, not that one. If you search in the Google Play Store or the Apple App Store, you should be able to find this app. I'm not 100% sure that it's on Apple. I'm pretty sure. If it's on Android, usually it's they first did it for Apple. So I'm assuming it's there. This is my favorite one. I've tried all of these. I don't like any of them. A lot of them have mistakes. This is my favorite one. So this is the one I've installed. Trust me, I've tested all of them. This is my favorite one. So open this one. Okay. And then I type in CCl2, and it's this is one reason I like this app, because it puts common molecules, and I don't have to keep typing it. So you just start typing it like it knows. It's smart. Okay, so I type in that, and there you go. That's the molar mass. Another cool thing about this is if you're interested in the molecule, you can tap on it, and it does a Google search of that molecule. So And then you could Wikipedia this, and you could start learning about Freon, how dangerous it is. It starts messing up the ozone, makes holes. Yeah, its manufacture was banned in 1996. Okay, so where was I? No, I want the molar mass app. So okay, so 120.91 is my molar mass. So I go 120.91 grams in 1 mole. And I wanted grams down there so that it cancels with that one. Okay, and I want to keep going until I get to molecules. So now I'm here at the mole, and I want this one, molecules. So next conversion factor is this one, Avogadro's number. So I'm going to write 1 mole to match it up with this unit. And I write 6.02 times 10 to the 23rd molecules. I'll just write molic like that. Okay. And now we go to our calculator. Where was my this? And I really like this fraction form. You enter it all in one shot, 5.56, and you don't need parentheses. So 6.02 times 10 to the 23rd. And then use that arrow key, you get down to the bottom half, 1,000 times 120.9. Oop. 120.9, and I think that's the end of it. Yeah, that's it. So hit enter, and there's my answer. So this number, as usual, the number they give you in the problem determines your sig figs usually. Okay, so I should have 3 sig figs. So I'm going to write 2.77 times 10 to the 19th molecules, which totally makes sense. You should have a giant number because molecules are very, very small. So molecules of Freon. Okay, a little bit harder. What is the mass of chlorine in 5.56? So this doesn't help you a whole bunch for this one, but I will tell you what though, if you're ever lost in a question like that or any kind of like chemistry conversion question, get it to moles. Get it to moles. Get whatever they give you, change it into moles, and then see what you can do from there. Okay, so we're going to try to get to moles from the start. So this is part 1, and here's part 2 of this question. So I'm going to go 5.56 milligrams. I already actually did some of this work on the first part. Okay, so I'm going to change this into moles. So it's basically the first 2 steps are exactly the same, 1 mole, and you could just basically just copy that from the first part. So my milligrams goes away, grams, and grams. And so what directs me here is I want grams of chlorine, okay, from the beginning, and I have this. Okay, so this is what I'm given. It's like a game, unit conversions and chemistry conversions. It's a game. So that's what I'm given, and this is the number I'm given, and this is the number I'm looking for. I'm looking for grams of chlorine. So if I get it to moles of chlorine, I can just use the molar mass and get it to grams of chlorine. So the question is, how do I get it to moles of chlorine? Well, if I get it to moles of substance of the molecule, I see that there are 2 chlorine atoms in 1 molecule. So every molecule of Freon has 2 chlorine atoms for every 1 molecule of Freon. So that's going to be actual conversion factor. Is there's 2 of those for every 1 of those. So that's the ratio or proportion. Okay, so this gives me CCl2F2. So there's that many grams in 1 mole of CCl2F2. So here's where I get to moles of chlorine. I'm going to go in 1 mole of CCl2F2. There are 2 moles of chlorine. So you can go mole to mole within a substance. That's what I just did right here. Okay. So I went mole to mole. Sorry, I keep messing these slides up. I went mole to mole within the substance. So that is totally legal. You can do that. Okay, it's called Dalton's law of definite proportions. Okay, times, and now this is kind of like my key point here is getting to moles of chlorine. Now all I need is a molar mass of chlorine, and I'm home free. So I go 1 mole of Cl is 35.45 grams of Cl. Okay, and I put this all in my calculator. I did this ahead of time. I think you're used to me typing stuff in my calculator. It takes forever. I did this problem ahead of time, and I got 3.26 times 10 to the negative third grams of chlorine. Okay, and or you could write this as 3.26 milligrams of chlorine. Okay, now time for you guys to try. So here's the your turn. I wanted to make a note. They tell you right here. They say this little dot H2O. These are in the formula are called waters of hydration. What this means is on a formula unit of aluminum oxide, there are 2 water molecules attached to it. There's 2 of these guys stuck to this, like in real life. Like if you had a crystal of aluminum oxide, there would be 2 water molecules stuck to it. Okay, so and it's actually part of the formula. So for the molar mass, it would be 2 waters plus whatever this molar mass is. So let me get the molar mass. That's the only part I'll do on this. Let's see. Yeah, it does it for me. So I entered it in the app like this. I'll show you what I was doing. You have to enter it kind of weird. These barely ever come up, so but this is how I entered it. I put an H2O in parentheses, and then I put a 2 after it so that the 2 would distribute to the water. And then that should be the molar mass, 138 grams per mole. So it's 138 grams per mole, or 1 mole of Al2O3 dot 2H2O is 138 grams. Okay, so give this question a try. Use the example. This one is very much like the one that I just did when I got the mass of chlorine that was in the sample. Okay, so that's the end of the video.